cross correlation. In cross correlation, Rxy is equal to E of x of t, then E of y of t. X of t is a one random variable, y of t is completely another random variable, may be taken from the different sample space. Okay, we are taking two random process from the different sample space. Okay, completely they are different. Then if you try to find out the correlation, then that is the cross correlation. So just formula, both the formula is same, whether you are taking the random variable or random process from the same sample space or from the another sample space. So again, already we have taken the samples from the different sample space. So that's why here we may not introduce the time delay. Okay, that's why again, this is not going to be function of tau. Why? Because here I have not introduced any delay parameter. Why? Already it has been taken from another sample space. Okay, so really the answer really depends on the actual relationship between x and y in the corresponding time, that is cross correlation. Then what are all the properties of correlation? Properties of correlation. So these properties may not be evident, but just I am listing out the properties. But during the course of time, once if you solve many number of problem, you can realize these properties. Say autocorrelation function is always even function of time. Even function of tau, because already it is function of tau, and also it is even function. Mostly it is even function. We know that if it is even function, Rxx of tau is equal to Rxx of minus tau. That means the delay may be positive or negative. Okay, both are same. Then the second property is Rx of tau will have maximum value at tau is equal to 0. This is the another second properties. Any autocorrelation function, when you put tau is equal to 0, that time it will have maximum correlation. Then autocorrelation function for any other value, say Rx of tau, is for another value other than tau, definitely it should be less than or equal to Rx of 0. Okay, Rx of 0 is the maximum value. So for other values of tau, the value may be equal or it may be less than equal. So these are all the some properties of the correlation, autocorrelation, mainly autocorrelation. Properties of autocorrelation. So even function of time, it will have maximum value at tau is equal to 0, and then Rx of tau is less than or equal to Rx of 0. And from the previous slide, we can understand. See, we have taken some function. For that autocorrelation function, we have defined, okay, a square by 2 cos of 2 pi fc tau. We know that cos by default it is the even function. Cos is always the even function. This is a simple example, though, but for another signal, also for any other signal, the signal may be random or may be deterministic, but in general, autocorrelation function is always even function of tau. Always even function of tau. That is the important understanding here. Okay, then we'll define some of the types of the stationary process, random process. We know that there are stationary random process and then non-stationary random process. In the stationary random process itself, there is triple S, strictly stationary random process, then wide sense stationary random process. So one by one we